Okay, today we will discuss the interrupt structure of 8051. Already we covered architecture of 8051, code structure of 8051 and memory organization of 8051. Today, interrupt structure of 8051. Now, with the help of any controller, we can construct any embedded system. First, we will see example. First example is fingerprint sensor based security system. This is one of the embedded system we are constructed with the help of microcontroller. Okay, in our case, we are considering micro 8051 microcontroller, and there is a one microcontroller, that is 8051, and it is interfaced with a number of input output devices as per the problem statement. Now our problem statement is fingerprint sensor based security system. Okay, now this system you are connecting to the entrance of the company. Otherwise, in our college campus also we having this fingerprint sensor based security system. Okay, when employees entered into the campus, at that time they are giving attendance with the help of this type of embedded system. Okay, there are two ways to give the attendance. First is either fingerprint sensor. Just keep your finger on this sensor and give the attendance. Suppose the sensor is not working, in that situation they can enter their ID number with the help of keypad. Means there are two ways to input the data from the outside world into the controller. In this fashion, controller just take the input from the input devices. In this case, there are two input devices. One is a fingerprint sensor and second one is a keypad. Through this input device, the controller get the input. After that, controller just take that data and display on the LCD for customer convenience. For example, the display name of that stuff along with the today's date, time, etc. Means whatever message you want to display for use customer point of view, you can display that message on the LCD. Similar way, suppose that authorized person entered. That time you want to open the door of that company, or you want to open that gate. In that case, you are just giving, suppose that is authorized person, then controller will give signal to the DC motor to open the gate. Suppose that is unauthorized person, it will not provide any signal to the DC motor to open the gate. In this fashion, you can construct the embedded system to check that is authorized person or not. According to that, we are just writing the program in the controller. Controller take the input from the input devices either through fingerprint or keypad. Just check it is authorized or not. Suppose it is authorized, then only it will give command to the DC motor to open the door. Similar way, the same name as well as the ID number, it is displayed on the LCD screen. And suppose unauthorized person entered, that time not permitted, otherwise not valid, like that message display on the LCD screen. In this fashion, you can write any program on the microcontroller to work out our problem statement. Similar way, suppose staff entered through this sensor or keypad, and that input is given to the microcontroller. Then same input is passed to the computer or computer server for further action. Okay, similar way, you are just giving reply to the customer through alert, turn on the buzzer, say siren, otherwise just attach the speaker to say thanks, like that. You can give any message, you can announce any message through the help of buzzer, singers, or loudspeaker, etc. Similar way, you can attach relay for related operation. In this fashion, you can construct any embedded system using the microcontroller. That is the first example I am saying. Similar way, I am just giving the second example, that is this is your embedded product or embedded system you are constructing with the help of 8051. Means you can perform your mini project as well as MA activity based on this also. That is GSM based home security system. In home security system, there is the one controller is there. Number of input devices are there. Number of output devices are there, etc. For example, in this problem statement, that is GSM based home security system, there are three sensors are shown here. That is a LPG gas sensor, IR sensor, and fire sensor. Suppose any LPG related problems is there, then sensor will sense that and give input to the controller. Suppose anybody is in front of the door, IR sensor will take the input and pass to the controller. Similar way, suppose any fire type of issues are there inside the home, that fire sensor will sense that that data or that parameter and give input to the controller. Now in controller we are writing the program to take action on this inputs. Okay, means such a type such as turn on the door or open the door, like that. And for that we are opening and closing the door with the help of motors, like that. Similar way, we are alerting the customer by turn on the buzzer or siren. Means somebody is there, somebody LPG gas related issues there, fire related issues are there. For that we are just alerting the customer by turning on the buzzer or siren. Similar way, we can providing message to the customer through the GSM based module. GSM module, that is one of the module through which you are just giving message to the customer. Suppose your customer is away from the home, till through the message you are sending the alert message to the customer. Okay, in this fashion you can construct any embedded system with the help of microcontroller. Every time there is one microcontroller and number of peripherals surrounding to that. All of you agree for this situation? Just give all of you agree for this? Okay, now we are going for the next, that is interrupt structure. Up to this we just know that microcontroller are interface with number of input output devices, that is nothing but your external peripherals. Means different types of sensors are there, motors are there, buzzers are there, LCD displays are there, monitors are there, etc. Means number of devices are attached to the microcontroller to construct the embedded system. Okay, now next point. Now what is the role of microcontroller there? Means the picture is shown here. There are number of input devices are there, output devices are there along with the microcontroller. Now what is the role of microcontroller here? That is the question. Now the duty of microcontroller is to provide service to everybody. Whenever suppose anybody wants service from the microcontroller, microcontroller must provide service to it. All of you agree for this? Means the duty of microcontroller is to provide service to those devices who are requesting for its service. Agree for it? Okay, then we will proceed for the next part. Now microcontroller role is to provide service to the input output devices. Now there are two ways to provide the service. Now which are they? First one is a pooling method. Through pooling method, microcontroller provide the service. Second method is interrupt method. Through interrupt method also microcontroller provides service to the peripheral, that is input output device. Now one by one we will see each method separately. Now first method is pooling method. In pooling method, again there are number of input devices are there, output devices are there surrounding to the microcontroller. Now in pooling method, microcontroller continuously check one by one each device separately and just check anybody want his service or not. Means for example, microcontroller first pull first input device and check he want his service or not. Suppose no, then he will ask question to next second input device, he want his service or not. Then third, then fourth. Once input section input devices are over, then he will ask the output devices. First output device, second output device, third output device. One by one controller is pull each device separately and just check anybody want his service or not. In this fashion, microcontroller just pull one by one device and check if they want its service or not. And suppose anybody wants service, that service is provided to that particular device by microcontroller. In this fashion, microcontroller is just pull one by one device and just check anybody wants service or not. Okay, means microcontroller is not doing anything else. It is just monitoring the status of all devices continuously. Means it is busy with that task only. Means microcontroller is not doing its own job. It is just monitoring others and just check anybody want service or not, and suppose anybody want, that service is provided by microcontroller. But microcontroller is not doing any its own job, its own task. It is not executing its own task, and that is nothing but wastage of time. And that's why I'm saying that in pooling method, microcontroller keep checking the status of other devices, and while doing so, it is not doing anything else. It is just continuously monitoring the other status. Means it is nothing but wastage of time. That's why we are saying that pooling method is non-efficient, because microcontroller is not doing its own job. It is continuously pull one by one device sequentially, and it is remain in a loop, and that is nothing but wastage of time. And that and this is a major drawback of pooling method. To avoid that, we are going for the next method, and that method is called as a interrupt method. All of you agree for this point? Okay, then we will proceed for the interrupt method. Now this is the interrupt structure of 8051. One by one we'll see that. Okay, we already know that there are 5 interrupt sources. That is, first interrupt is related to INT0, that is external interrupt INT0. Next INT1. Next AND gate is related to interrupt related to timer 0. Then next AND gate is related to interrupt related to timer 1. Then next AND gate is related to interrupt related to serial communication. In this fashion, there are maskable 5 interrupt sources are there, and one more source is there, that is the reset. Okay, in this fashion, total 6 sources are available in 8051. 5 are maskable, that is shown here with the help of AND gate, and one more is non-maskable interrupt, and that is your reset. Then one by one we will see what do you mean by maskable and what do you mean by non-maskable. Okay, first we will see what happens when interrupt arises. Okay, now initially controller execute its main program. Okay, when interrupt arises from any device, that time CPU just stop its working and just jump to the separate code which is designed by the programmer to provide service to that respective device. Means, for example, main program is executed by the programmer. Okay, in between interrupts coming from other side, means interrupt coming from the external devices, or interrupt is coming from the timer 0 or timer 1, or interrupt generated from the serial communication. In this fashion, when interrupt arises, that time programmer main program just stop as here only, and it is jump to the next separate service routine which providing service to that device. Okay, and that's why it is called as a interrupt service routine. Means main program stop in between, and it will move to the other code, and that code is called as an interrupt service routine. Interrupt service routine provides service to that particular device, or it is providing service to that interrupt. Means interrupt is coming from either timer, it is coming through the external peripheral, or it is coming through the serial communication. Whatever interrupt arises, according to that, main program gets stopped and controller will jump to the interrupt service routine. After completion of interrupt service routine, it will go back to the main program. For example, suppose you are giving interrupt through the printer. Now main controller is doing its own task, and suppose before performing this task, controller given some task to the printer to print. Okay, and the actually controller speed is more as compared to printer. Printer take more time to print something. Once print is over, it is just interrupting the controller on the particular pin, that is INT0 and INT1. These are only 2 pins. for external peripheral. Yes, anybody wants service from the microcontroller, they are interrupting on that respective pin, that is INT0 and INT1. When any interrupt arises, immediately controller jump to the interrupt service routine, and there it is take the address of ISR, that is interrupt service routine. It will execute here interrupt service routine. After completion of it, it will go back to the main program and it will remain in the main program. All of you agree for this method? Means here controller is not wasting its time. It is just executing its main program. Okay, and when anybody interrupt arises, that time only we will go just going for interrupt service routine, and with the help of interrupt service routine, it is just serve that device or that interrupt, and it will go back to the main program, and main program will execute further. In this fashion, controller is doing its task along with providing service to other. Agree for this? Okay, then we will proceed for the next. Now steps for execution of the interrupt. Now first is when interrupt arises, finish current instruction and save the PC on stack. Normally we know that your program is executed, main program executed by the programmer, or it is executed by the controller, and for that next instruction is always shown by the PC. PC is nothing but your program counter. Continuously program counter showing the next location to fetch. Yes, microcontroller executing the program by first fetching the code, then it is decoded, and then it is executed. Okay, when it is executed any instruction, always PC, that is program counter, just showing the next memory location from which controller will fetch the next instruction. At that instant it is just showing, for example, interrupt arises at 2000. Okay, at location 2000 interrupt arises. So क्या होगा? Then your PC status, that is 2000, just hold on a stack. Now what do you mean by stack? Stack is the some memory location you are dedicated for preserving the return address as well as to hold the dedicated data. Means some portion of memory you are declared as a stack. Stack is the memory location is used to hold the return address as well as to hold the dedicated data. In this fashion, when interrupt arise, that time controller will just complete its current execution and it is save that location. For example, 2000, it is a save on a stack. All of you agree for this? Stack is nothing but your memory location to hold the return address. Okay, means for in this case your address is 2000, that is hold on a stack. After that controller jump to a fixed location in a memory which is indicated as IVT, that is interrupt vector table. Some portion of memory is dedicated as interrupt vector table, means which hold interrupt vector table, depends upon type of interrupt. We already know that there are 6 type of interrupt sources. One is external interrupt INT0, next one is external interrupt INT1, then timer 0, timer 1, serial interrupt, and last one is the reset. Each one, when any respective interrupt arises, each one having their interrupt service routine. Okay, but where is the interrupt service routine? That starting address is held by interrupt vector table. Means whenever any interrupt arises, means serial interrupt, timer interrupt, or external interrupt, or reset arise, that time controller will jump from main program to ISR. But where is the ISR? Where is the starting address? Where is the starting address of ISR? That is preserved into interrupt vector table. After this slide, we will show that I will show that interrupt vector table to you. Okay. Now jump to the fixed location in a memory, that is your interrupt vector table, depends upon which type of interrupt arises. Next location is that interrupt service, interrupt handling code is is already known that it is known as a interrupt service routine. Okay, and the starting address of interrupt service routine is available in interrupt vector table. Then just take the address of ISR from interrupt vector table and start executing interrupt service routine. This interrupt service routine is executed. Starting address of interrupt service routine is taken from interrupt vector table, and then interrupt service routine executed continuously one by one till return I, return from interrupt instruction is not there. Means all instruction is executed one by one continuously, and last when interrupt I instruction is coming, return I is nothing but your return from interrupt sources, interrupt service routine, and that time the starting address of main program is popped from the stack and it start the main program. Means here controller initially executing the main program, in between interrupt arise. That time controller stop working here and PC hold on a stack with the help of which instruction? Push. Means everything is pushed on a stack to hold or preserve that return address as well as dedicated data. Then controller jump to the interrupt service routine to provide service to that interrupt. But we don't know the starting address of ISR, interrupt service routine, and that's why controller jump to interrupt vector table, and from interrupt vector table you are taking the starting address of ISR. Each interrupt source having different ISR, each one having different ISR, each one having different starting address, that is hold in interrupt vector table. Okay, just take the address of interrupt service routine and perform interrupt and just execute this interrupt service routine program or code. At the end of this ISR, there is which instruction? Return I. When return I instruction is coming, that time controller will pop all the return address as well as data from the stack, and it will jump to the location. Means here 2000 we are preserving on a stack. Same thing is coming back here, and PC is allocated with same address, that is 2000, and for next action is executed continuously. For this I am just giving one live example. For example, we are studying from LKG to B. Yes. Suppose our student get failed in particular year. For example, main educational program is started from LKG up to B. In between, in first year, suppose first year some student get failed. At that situation, in the memory, they know we failed in first year. They are just going for interrupt service routine. They serve, it is just doing that. They are clearing all subject from first year and they are coming to the next, that is second year. Means they know after completion of first year they are jumping to the second year. Means the second year address you are preserving into the stack. After completion of ISR, we are coming back to the main program to complete the next education, and for that we pop all the data from the PC, and from PC we are getting the data of second year, and that second year will start, and in this fashion main program execute one by one from LKG to B level. All of you agree for this example? Means in the memory we are preserving that data where we are interrupted, and after completion of ISR we are started from that location. Suppose we are not keeping this at return address, that time what happens? Every time controller will jump to the original position and it will start from the origin. In between interrupt arises, it go to interrupt service routine, again go back to the original, and in this fashion never main task will execute. To avoid that thing, you are preserving the return address on a stack with the help of stack. All of you agree for this point? Okay, then we will proceed for the next part, that is interrupt sources and its location. Now 8051 having 6 interrupt sources, and it is shown in this table, and that table is called as a interrupt vector table. All of you agree for this point? Just give me the answer on a chat first, and then we will proceed for interrupt vector table. This idea is clear to you? Just give the input to me. Okay, then we will proceed for the next part. Now next are interrupt sources. We know that there are 6 interrupt sources are there, and what is the location of that interrupt service routine, that is held in the interrupt vector table. Okay, now here 6 sources are there. First source is reset, next is external interrupt, that is int 0, next is timer 0, then external interrupt 1, that is int 1, timer 1 interrupt, and serial interrupt. In this fashion 6 interrupt sources are available, and when this type of interrupt arises, we are going for interrupt service routine to serve that device or to serve that interrupt. And for that ISR, it is where is the starting address of ISR is preserved into particular location. Means for example, reset interrupt arises, that time controller just go to which location, 4 zeros, and it is take the starting address of ISR. Okay, and then it will jump to that respective ISR. Similar way, suppose interrupt arises from external interrupt 0, that is int 0, that time controller just go to which location, 0003, means external peripheral giving interrupt on int 0. int 0 is nothing but your P 3.2, that is pin number 12. When interrupt arises on this P, that time controller know that it is coming from int 0, and that time controller just move to which location, 0003, and from this location it will take the starting address of ISR and it will jump to that ISR. Next one is interrupt related to timer 0. When given time in timer 0 get O complete, that time it become overflow. Okay, means for example timer 0, we are some specific time you are preserving in timer 0, for example 30 minutes. After completion of 30 minutes it will overflow, and that time it is just interrupting the controller, and at that situation microcontroller jump to which location, now it is related to timer 0, that's why microcontroller jump to which location, 000B. From this location taking the starting address of ISR, and then controller jump to the ISR. When controller sends the signal on INT1, that is external hardware interrupt, that is INT1 on pin number P 3.3 and pin number 13. On this pin you are getting the interrupt. At that time controller jump to which location, 0013. Here from this location taking the starting address of ISR and jump to the ISR. Similar way, interrupt coming from timer 1, that time controller will take the starting address of ISR from location 001B. Similar way, suppose interrupt generated because of serial communication, that time controller jump to which location, 0023, to take the starting address of ISR. In this fashion, any interrupt arise, controller jump to respective location and take the starting address of ISR, and from that starting address it will start executing one by one all instruction of ISR, that is interrupt service routine, to serve that interrupt. Okay, and after completion which instruction is there, return I, means return from interrupt, then it will go back to the main program. All of you agree for this concept? Okay, means before going for ISR, it is take location of ISR, starting address of ISR from this location, respective location, means which type of interrupt generate, according to that, from that location take the starting address of ISR. Next is related to types of interrupts. Now we know that there are two types of interrupt, that is maskable interrupt and non-maskable interrupt. Means maskable interrupt means we can avoid it as per the situation, and non-maskable interrupt means we can't avoid it. You must serve it. For example, day-to-day life, we are performing number of activities. For example, we are playing the games. We are see that movies. Then we are going for picnic. We are taking we are doing our academics also. Means we are doing some study related to exam point of view. Okay, these are our day-to-day life activities. Okay, every day we are doing all these things. Okay, but during exam time we are just we are concentrating on our study only. We are avoiding others. Means we are avoiding to play the games, see that videos, and going for picnic like that. Means we are just focusing on our specific task, that is study only. Means we are masking others, means we are avoiding others, and in this fashion we are avoiding other, that is nothing but you are masking others activity, and we are focusing on a dedicated task, that is we are concentrating on our studies only. Okay, and non-maskable interrupt means at any condition you must provide service to that. Means here in maskable interrupt, suppose anybody are calling us for play the games or see that videos or going for picnic, that time we are just avoiding them. Yes, but non-maskable interrupt means suppose this is a exam time and we are focusing on our studies, and at that situation suppose some critical issue arises. For example, some medical issue arises. In that situation we are just keeping that is unavoidable situation. That time we are just giving prior service to that health first, and then we are doing that study part. Agree for this point of view? In this fashion, controller also is busy with number of activities. Okay, controller is busy with number of activity. Every time it is providing service to all the peripherals. But suppose in such some situation, controller is doing some critical task and he don't have sufficient time to serve other peripheral, external peripheral, and that time controller having authority to mask other activity. Means even anybody wants service from the microcontroller, it is just it is in controller hand to avoid that. I don't have sufficient time, I am doing some critical task, I don't want, I will not provide service to you. In this fashion it is maskable interrupt, and non-maskable interrupt means you must serve that. Even you are doing some critical task, you must stop there and just go for your critical task. Means for example, in industry, suppose in your industry some boiler system is there. Suppose it in boiler system, suppose it cross the temperature limit, and in that situation you must take action on it, otherwise it will damage your plant. To avoid that part you must take the action. Anytime suppose it cross the limit, you must take the necessary action, otherwise it will damage your plant. To avoid that, that is your non-maskable interrupt. In this fashion, every time interrupt is having two types. Maskable means you can avoid it, and non-maskable means unavoidable interrupt. You must serve it. Agree for this? Okay. Now just read it. Maskable interrupt, that which can be ignored by the controller while performing the task. That is maskable interrupt. We already know that there are 6 sources. Out of that, all interrupt sources are maskable except reset. Means reset is your non-maskable. Reset is your non-maskable interrupt. Means you must provide service to it. Okay, otherwise it will damage your plant or damage your embedded system. Okay, you must provide service to it first. Okay, and in this fashion you are just splitting your interrupt into two type. One is maskable, you can mask it or ignore it as per your demands, as well as non-maskable means you must provide service to it. And in our interrupt sources, reset is non-maskable interrupt. Agree for this? Okay, then we will proceed for the next part, that is this maskable and non-maskable. Non-maskable means we can't avoid. We can't write anything. You must provide it. Provide service to it. Okay. Maskable means you can provide service to it. Otherwise, ignore it. That is in your hand. Okay. And that masking and non-masking is done with the help of one register, and that register is called as a interrupt enable register. That is IE register. Interrupt enable register. With the help of this, you are enabling or disabling the interrupt. Enabling means you are permitting that interrupt, and disabling means you are ignoring that interrupt. In this fashion, with the help of IE, we are able to enable or disable the interrupt as per our choice. Now, what is the structure of IE? That is the next question. And for that, just see this figure. Here, this is a 8-bit register. IE, that is interrupt enable register, is a 8-bit register. Okay. Now, each bit is located for specific interrupt source. We know that there are 6 interrupt sources. Out of that, 5 are maskable, and one reset is non-maskable. We can't disable it. Okay. Now, these are the 5 sources. Bit number 6 is not used. Bit number 7 is for EA, that is enable all or disable all. Means, for example, suppose my controller is busy with some critical task, and he don't want to provide any service to any interrupt. Means he don't want to provide service to timer 0, timer 1, external interrupt INT 1, INT 0, or serial interrupt. In that situation, instead of making everybody disable, controller programmer will just disable it here. Disable all. Means suppose this bit is 0. Even interrupt arises from one of the source, it will not proceed to the controller. When this is 1, that is enable all, that time only this interrupts proceed to the controller. Suppose, okay, all of you agree for this? Overall enabling and overall disabling. 1 means enable and 0 means disable. Now, in some situation, controller don't want to provide service to timer 0. In some situation, controller don't want to provide service to timer 0 only. All other interrupt it will accept and provide service to others, but it don't want to provide service to timer 0. In that situation, we are just writing here this is 1 because we are allowing others. That's why all others are 1 1 except timer 0. We are just making this as a disable. Means we are just writing here 0 and all others are 1 1. Agree for this? In some other situation, sometime controller don't want to serve serial communication. That time it will just disable serial communication. Means this particular bit number 4 is 0. Means serial communication is disabled and all others are enabled. In this fashion, as per your application, you can enable or disable any interrupt source other than reset. Means that is in your hand. In some situation, suppose the controller want to serve only timers, that is timer 0 and timer 1. That time that respective are enabled and all others are disabled. In this fashion, you can write proper number in this register, that is interrupt enable register, for enabling and disabling the respective interrupt source. Agree for this? Okay. Now according to that, just see this figure. In this figure, there are AND gates are there, and 2 AND gates. One is interrupt source INT 0, that is interrupt is coming from the external peripheral, and that is ANDed with the enable external source. Suppose this is 1 and this interrupt arises, that time only this AND gate is on and proceed to the next. Suppose interrupt arises on this particular pin, that is INT 0, but this is disabled, means EX0 is 0. In that situation, AND gate is, what is output of, this is 1 and this is 0. What is output of AND gate? 0. Means nothing pass further. Okay, means for enabling this AND gate, this enable bit must be 1. That time only interrupt will proceed next. This is AND gate controlling whom? That is INT 0, external interrupt 0. This AND gate controlling INT 1. This AND gate is active only when this is 1. Enable is 1. Suppose this is 0, AND gate will not proceed INT 1 further. Similar way, this AND gate is for timer 0. This AND gate is related to timer 1. This AND gate is related to serial communication. In serial communication, there are two sources. One is the transmission is over. In serial communication, we know that there is only one pin. In parallel communication, all 8 bits are moving from one device to other. But in serial communication, all bits are not moving at a time. There is only one bit to transfer. Only one wire is there in between the two devices. One by one bits are moving. Yes, when all 8 bits are out, that time TI become 1. Similar way, when all 8 bits are entered into the controller, RI become 1, means receive interrupt is generated. When this type of interrupt arises, that time only this is OR gate, either transmit TI interrupt or RI. दोनों में से कोई भी आया तो OR gate output become 1, and that is interrupting this AND gate. Okay, when now ES, that is external serial communication, is enabled and this is interrupt generated from TI or RI. In that situation, AND gate output becomes 1 and it is proceed further. All of you agree for this? In this fashion, we are controlling how many sources? 5 interrupt sources. That is external interrupt 0, external interrupt 1, timer 0, timer 1 and serial interrupt with the help of these 5 AND gates. Okay, after enabling, it is passing to the OR gate. OR gate means any one interrupt arises, it is proceed to next. Either interrupt generated from interrupt 0, it will proceed because this is OR gate is there, and that's why it is proceed up to this point. Means one arises here. Means interrupt generated from one of the source, it is reach up to this location. But controller don't want to provide service. That time controller just disable this EA. What do you mean by EA? External enable all or disable all. This is one means enable means this is proceed. This AND gate will allow this interrupt to move further. Suppose this is disable. EA is equal to 0 means disable all. Interrupt arise reach up to this point, but it is not cross this AND gate and proceed further. Yes, means this is proceed further only when EA is equal to 1 means enable all. When this is enable all is 1, that time only interrupt proceed through across this AND gate and proceed to controller side. Okay, then it is interrupting the CPU. When before that CPU already executing the main program. Now interrupt arise and it is disturbing to the CPU. That time CPU just stop its current working. The starting next address of program is hold on a stack and it is jump to the ISR. But initially we don't know the starting address of ISR, and that's why controller just go to interrupt vector table which is having the address of ISR. Take that address of ISR, it will execute this ISR one by one. All code from ISR will execute. At the end of ISR, there is which type of instruction? Return I. When return I comes, that time controller coming back to the main program by taking the return address from the stack. And for that, it is just using which instruction? Pop. Pop the return address as well as the dedicated data which is preserved when it is jumping on ISR. Agree for this? Yes, give me the answer on chat first and then we will proceed. First give me the answer on a chat first. Any difficulty up to this? Any difficulty? Yes, Then which type of difficulty you have? Just tell me which type of difficulty you have. I will repeat it again. Any difficulty you have, immediately just tell me which difficulty. Okay, no difficulty. Okay, then we will proceed for the next part. Next part is interrupt priority. Now we know that when interrupt arises, controller take the starting address of ISR and it is just executing that ISR. But in some situation, two interrupts arises at a time. In that situation, how controller handle that situation? That is the question. So suppose there is one interrupt source arise, controller just take the starting address of ISR and providing service to that interrupt. But suppose two interrupt requests arise at a time, then what is the role of controller? How controller handle that situation? That is the question, and that's why we are assigning priority, or 8051 assigning priority to the interrupt source. And what is that? That is mentioned in this table. In this case, we know that there are 6 interrupt sources. One is reset, then interrupt from external interrupt 0, INT 0, then interrupt through timer 0, then interrupt INT 1, then timer 1, and then serial interrupt. As you are moving from reset to serial interrupt, priority reduced. Means reset having the highest priority and serial communication having lowest priority. Means suppose two interrupts arises at a time. For example, interrupt from timer 0 and timer 1 arise at a time. At that instant, timer 0 having highest priority as compared to timer 1. And that's why controller will serve timer 0 first and then it will serve timer 1. Suppose two interrupts arises, that is timer 0 and serial interrupts coming at a time. At that situation, controller will serve timer 0 first and then it will serve serial communication interrupt. In this fashion, controller giving priority as per this table. A reset having highest priority, then second priority is INT 0, third priority is timer 0, fourth priority INT 1, fifth priority is timer 1, and sixth priority or lowest priority is given for the serial communication. All of you agree for this point? But now this is the normal sequence of priority. But suppose I am just performing practical on serial communication. Means I am not interested in timer 0, timer 1 or external interrupt. I am interested in a serial communication. That time I have or customer or programmer having choice to change the priority as per their requirement. In that situation, suppose I am performing practical on serial communication. That time I will give highest priority to serial communication. That is my requirement as per the application. And at that situation, our programmer or customer want to change the priority. This is the normal flow, but now I want serial communication having highest priority. Reset is by default, it is highest. No one can avoid change. No one can change that. Or for all other cases, we can change as per our problem statement. Okay, reset always it is highest because it is non-maskable. No one can avoid that because it is a non-maskable interrupt. All other are maskable, means we can change the priority as per our problem statement. Okay, now we can change the priority. Now my requirement is I want to change the priority, and for that I am taking help of one register, and that is called as the interrupt priority register, that is IP register. Okay, now in IP register, this is the structure of IP register. This is again 8-bit register. Out of that, these 5 bits, first 5 bits are dedicated for particular interrupt. Okay, first bit is bit number 0 is dedicated for external interrupt 0, that is INT 0. Next, bit number 1 is dedicated for timer 0. Next, second bit is dedicated for external interrupt 1. Third bit is dedicated for timer 1. Fourth bit is dedicated for serial communication. Okay, and fifth bit is for timer 2. But in our 8051, it have only two timers, that is timer 0 and timer 1. Suppose you are going for 8052 or 53. In that situation, there are three timers. Yeah, 8052 having three timers, that is timer 0, timer 1 and timer 2. And in that situation, you are considering bit number 5. Up to that, up to 8051, there are only two timers, timer 0 and timer 1. Okay, now you are just changing the priority as per your choice. Now there are two levels are there. One is high, second one is low. 1 means high and 0 means low. In this situation, I want normally serial communication having lowest priority. But when I performing serial communication practical, that time I want serial communication having highest priority. In that situation, I will just make this as a 1. 1 means high priority and 0 means low priority. Means I will just make this as a 1 and all others are 0, 0, 0. Means in our program, I just making bit number 4 as a 1, which indicate and that number I am placing into which register? IP register. IP is equal to 0, 0, 0, 1, 0, 0, 0. Means I am just making bit number 4 as a 1. Means and that number I am placing into interrupt priority register. Means I am just giving high priority to serial communication and all other having low priority. In that situation, suppose interrupt arises from serial communication, that is served first. Agree for this? In this fashion, you can change the priority as per your demands. Means in some situation, I am interested in timer 1. In that case, I will just make this as a 1 and all others are 0, 0. Okay. In this fashion, I can change the priority as per our demand that is mentioned within this slide. And this is your overall interrupt structure. Any difficulty? This is the overall interrupt structure. There are 5 maskable interrupts are shown here. There are for AND gate 2 inputs are there. One is interrupt generation and second one is enabling and disabling respective interrupt source. One is first AND gate is related to external interrupt on INT 0, that is P3.2. Then next AND gate is related to interrupt by INT 1, that is P3.3. Then next AND gate is related to timer 0. Fourth AND gate is related to timer 1. Next fifth AND gate is related to serial communication. In this fashion, you can mask the interrupt as per your choice. Then it is proceed. This is after that it is given to the OR gate. Any one of the interrupt generate, it is OR logic is there, and that's why it is proceeding further. When this becomes 1, then this AND gate is just check EA. EA means enable all or disable all. 1 means enable and 0 means disable. Suppose EA is equal to 1, that time this AND gate is on and the interrupt is proceed to the controller. And suppose EA is 0, that time this AND gate is open and interrupt will not reach up to the CPU. Okay, now when this AND gate is on, that time interrupt reach up to the CPU. Up to that, CPU is not wasting its own time, it is just doing its main task. Okay, and in between your interrupts arises at that instant. Whatever next address which is shown by the PC, that is program counter, that is hold on a stack. If that return address we are holding on a stack. For example, we are failed in the first year. That time we are just keeping the next address, that is second year address, we are preserving inside the memory. We failed in the first. After completion of first year, we are going to the next, that is second year level. Not on a lower KG again. All of you agree for this? And now, same fashion, now our controller is interrupted at location 2000. That time 2000 address is held on a stack. Then controller jump to the interrupt vector table. In interrupt vector table, holding the starting address of ISR. Each interrupt source having different ISR or different location or different starting address of ISR. As per the interrupt vector table, respective starting address is received by the controller, and then it is executing interrupt service routine to serve that interrupt. Okay, after completion of ISR, there is last instruction is always return I. Return I is written from the interrupt, and that time controller will take the return address back from stack with the help of which instruction? Pop instruction, and it will take that return address, and that return address is nothing but 2000. Okay, and from 2000 onward, next main program start executing till end of the main program. In this fashion, 8051 will handle the interrupts, and there are total 6 interrupt sources. Out of that, one is non-maskable interrupt, that is reset. No one can avoid it. Controller must serve that without any, otherwise it will damage the whole system, whole plant. And next one is maskable interrupts. We can control as per our choice with the help of IE register, that is interrupt enable register, by making respective bit 1 or enabling or disabling respective interrupt. One more last point we are that is priority interrupt. With the help of priority structure, we are just changing normal priorities, reset having highest priority and serial communication having the lowest priority. Okay, but suppose as per the customer choice or customer application point of view, customer want to change the priority, he or she can change the priority with the help of IP register. In IP register, each location is dedicated for particular interrupt source. Suppose that particular bit is 1, then it having highest priority, and 0 means lowest priority. As per this, we can change the priority and we can handle the any type of interrupt by 8051. Okay, thank you.